You won't believe the hilarious disaster that went down when Rabbit R1 tried their hand at coding for the first time. It's June 27th, 2024, and we're here to dissect what went wrong with the Rabbit R1 so you can avoid making the same mistakes in your own AI projects. Introduction to the Rabbit R1. I first encountered the Rabbit R1 at CES in January. Despite my initial skepticism due to the heavy use of buzzwords by its CEO, the device sold out its pre-orders within minutes. However, it quickly became apparent that the Rabbit R1 was not living up to the hype. It turned out to be little more than an Android app with dubious origins in crypto and NFT scams. Yet, the latest controversy involving the Rabbit R1 is perhaps the most alarming: the catastrophic code mistake. At the heart of the problem is the developer's choice to embed API keys directly into the code base, a practice universally recognized as a significant security vulnerability. This critical oversight was exposed by Rabbit2, a group focused on reverse engineering the Rabbit R1. Their investigation on May 16th revealed that the Rabbit codebase contained hard-coded API keys for essential services such as 11 Labs, Azure, Yelp, and Google Maps. Such hard-coded keys are susceptible to exposure through code leaks or repository mishandling, potentially granting unauthorized access to sensitive functionalities and data, underscoring the importance of robust security practices in software development. Why hard-coding API keys is a terrible idea. Let's break down why hard-coding API keys is such a critical error. API keys are akin to passwords and should be treated with the same level of confidentiality. When an API key is embedded in the codebase, it becomes vulnerable to exposure through several avenues, including accidental pushes to public repositories. There are bots continuously scanning public repositories for exposed keys to exploit. Moreover, hard-coded keys complicate the process of key rotation. Best practices dictate that production applications should rotate API keys every 30 to 90 days. For high-profile applications like the Rabbit R1, where reverse engineering attempts are expected, keys should be rotated even more frequently, potentially every week. This process can be automated to ensure continuous security without downtime. The specific risks with 11 Labs. Among the exposed API keys, the most critical was for 11 Labs, an AI text-to-speech platform integral to the Rabbit R1's functionality. Utilizing 11 Labs, the device converts text responses into spoken words. If compromised, this API key would allow an attacker to intercept and potentially alter every response generated by the Rabbit R1. Furthermore, they could manipulate or delete the AI voices hosted on 11 Labs, rendering every Rabbit R1 device unusable. This vulnerability highlights the profound impact of securing API keys to prevent unauthorized access and protect the integrity of connected services. The importance of securing API keys. To prevent vulnerabilities, API keys must be securely stored and encrypted. Effective storage solutions include using environment variables, secrets management tools, or encrypted databases. Logging access to these keys enables monitoring and detection of unauthorized attempts. In the event of a suspected leak, immediate steps should be taken to rotate the keys and mitigate any potential damage swiftly. These practices are essential to safeguard sensitive information and maintain the integrity of applications and user data. Rabbit's response. What's particularly shocking about this situation is Rabbit's response, or rather, its lack thereof. According to Rabbit2, Rabbit was aware of the exposed API key for over a month, but chose to ignore the issue, seemingly hoping it would go away on its own. This negligent approach left user data highly vulnerable to potential exploitation. Although Rabbit has since rotated its API keys, this incident underscores the crucial importance of proactive and responsible handling of security vulnerabilities to protect user data and maintain trust. Ignoring such issues can lead to severe consequences. Lessons learned. This controversy provides several critical lessons for developers. 1. Never hard-code API keys. Treat API keys like passwords and store them securely. 2. Implement regular key rotation. Automate the process to ensure keys are rotated frequently, minimizing the risk of exploitation. 3. Encrypt sensitive data. Ensure that any sensitive information, including API keys, is encrypted to prevent unauthorized access. 4. Proactive vulnerability management. Address security vulnerabilities immediately to protect user data and maintain trust. The Rabbit R1 story is a stark reminder of the importance of secure coding practices. Learning from these mistakes can help you create more secure and reliable applications. If you want to learn more about secure coding, thank you for tuning in. Don't forget to subscribe for more insights into the world of technology and AI. See you in the next episode.